It begins not with a bang, but with silence. For centuries, Venus loomed in our sky, shrouded in thick golden clouds, whispering secrets no one could hear. A planet so similar in size and structure to Earth that astronomers once dared to dream of oceans, rain, and life hiding beneath its mist. But those dreams died slowly, eroded by the searing truth. Beneath that beautiful veil was a hellscape, a world of relentless heat and crushing pressure, where metallic rains and volcanic fire sculpted the surface into something alien and unknowable. For a long time, all we had were brief, blurry glimpses, haunting photographs taken by doomed Soviet landers that survived only moments in the inferno. But the rest of Venus, its full face and story, remained hidden until Magellan. It was May 4th, 1989. The space shuttle Atlantis rose from Earth's surface, its engines trailing fire against the morning sky. And inside its payload bay, cradled in silence, was something special. Magellan, the first deep space probe ever launched by a shuttle. It wasn't flashy, it wasn't glamorous. In fact, it was made of recycled parts from past missions, Voyager, Mariner, Galileo. But it had a singular purpose: to pierce the clouds of Venus and map every scar and slope that lay beneath. After its long voyage, Magellan entered orbit around Venus and got to work. And what it sent back wasn't just data, it was revelation. Nearly 98% of Venus, seen in detail never imagined before, at resolutions sharp enough to distinguish features just 100 meters across. It was like tearing a blindfold off a familiar face only to realize you didn't recognize it at all. The old assumptions, the comforting comparisons to Earth, crumbled. In their place stood a planet utterly its own, brutal, raw, and beautiful. The first thing that struck scientists and stunned them was how smooth Venus looked. Not smooth like polished stone, but empty. Craters, which litter the Moon and Mars like age spots, were few and far between here. Only 940 were found across the entire planet. Most were surrounded by strange, sinuous patterns, not like the sharp-edged debris fields we're used to. These were soft, fluid, almost elegant, like flower petals unfurling from an explosion. Some even stretched hundreds of kilometers in delicate streaks, shaped not just by impact, but by the choking atmosphere itself. The craters didn't just speak of collisions. They hinted at a world that softened the violence, melted it into something hauntingly calm, and their scarcity whispered something else. Venus was young, not in a cosmic sense, it was born when Earth was, but in geological time, the surface had been wiped clean, erased, refreshed. At some point in the last 300 to 500 million years, the entire crust had melted and reformed in a planet-wide resurfacing event. The idea was staggering. Imagine every continent, every mountain, every trace of history on Earth vanishing under a wave of molten rock, then cooling into a blank slate. Magellan showed us the scars left behind. 85% of Venus is covered in volcanic plains, not the scattered cones we see in Hawaii or Iceland, but vast seas of hardened lava that stretch like frozen oceans of fire. There were volcanoes too, thousands of them, some small and dome-like, others massive and broad, their flanks flowing into the horizon. The largest of them, Mons, towered nearly as high as Everest. But it wasn't just their size or number that stunned scientists, it was their artistry. One formation looked like a stack of thick pancakes, wide and flat, cracked like cooling bread. Another showed rivers of lava carving paths hundreds of kilometers long across fractured plains. In places, thick, stubborn lava had oozed out slowly, piling up into bulbous mounds, too dense to move, cooling in place. The variety was astonishing. It was as if the entire planet had become a canvas for fire, and the mantle beneath had painted it in strokes of molten light. But beneath the beauty, there was unease. Magellan's radar painted a picture not just of the surface, but of the gravity field beneath. And from that, scientists saw something troubling. A world with no moving plates, no drifting continents, no subduction zones. Earth breathes through its tectonics. Volcanoes erupt, Mountains rise, oceans deepen. It's how our planet stays alive, how it recycles heat and carbon. But Venus? Venus is a prison. Its crust doesn't drift. It endures. Trapped, stagnant. And that stagnation may be what makes it hell. Because without tectonic movement, Venus can't bury carbon, can't release pressure, can't cool. The heat builds, the gases trap it, and the planet grows hotter and hotter until, eventually, the pressure is too much. And it bursts. A wave of eruptions swallows the world in fire, the crust melts, reshapes, and the cycle begins again. Standing on that surface, even in the imagination, is terrifying. The pressure alone would crush a submarine. The temperature melts lead. The air is poison, and yet the more Magellan showed us, the more impossible it became to look away. Because for all its violence, all its desolation, Venus was revealing something deeply human. It was telling a story of transformation, of silence that hides fury, of beauty formed through destruction. It was a mirror held up to the darkest possibilities of a planet like ours. What if we lost our balance? What if our tectonics stopped? What if our climate spiraled out of control? Magellan didn't just map a world. It confronted us with the truth that the cosmos doesn't owe us stability, that Earth is not the default, it's a fragile miracle. And Venus? Venus is the warning. The more Magellan revealed, the more Venus seemed less like a sister and more like a ghost. Orbit after orbit, year after year, the spacecraft carved out its map with radar eyes, slicing through the clouds, building an image from echoes and time delays. Each pass added to a mosaic of haunting complexity. What we saw wasn't just a scorched wasteland. It was a planet of paradoxes, quiet and cataclysmic, ancient and newborn, familiar and utterly alien. Venus wasn't dead. It was waiting. Among the most enigmatic features Magellan uncovered were the arachnoids. Yes, named after spiders. Imagine a pattern etched in rock, concentric rings like ripples on water, crossed by a web of radial fractures. Some stretched hundreds of kilometers wide, intricate and precise. Scientists had never seen anything like them. Not on Earth, not on Mars, nowhere else in the solar system. They looked like fossils of something colossal that had pushed up from beneath the crust, tried to break free, and failed. No one knows exactly how they formed. The best guesses involve deep mantle plumes, lava surges, or crustal buckling under pressure. But even those feel like incomplete stories. These features weren't just geological riddles. They felt like messages, scratched into the crust by forces we don't fully understand. And then there were the coronae. Named after crowns, these were immense circular structures, some larger than France. They resembled collapsed domes, vast, deformed rings surrounded by concentric fractures and lava flows. You could almost see the sequence in your mind. Magma rising, swelling the surface into a blister, then cooling and collapsing, leaving behind a cratered, broken memory of what once tried to rise. Some coronae were isolated, standing alone on the plains like monuments. Others clustered in chains, as if the planet's skin had been tugged and twisted by something deep and restless. Magellan's maps didn't just show structure, they told of motion, of stress, of resistance, and of release. But as these vast geological forms emerged from the data, a darker realization took shape. All of this, the volcanoes, the arachnoids, the coronae, seemed to belong to the same time frame. There were barely any signs of layering, no progression, no eras, almost no erosion. Everything looked new and old at the same time. Venus hadn't aged the way Earth had. It hadn't recorded a history, it had overwritten it, as if the entire surface had turned inside out in one apocalyptic moment and then stopped. This was the resurfacing event. It's still one of the great mysteries of planetary science. At some point, hundreds of millions of years ago, Venus may have undergone a planet-wide catastrophe, a release of internal heat so immense that the entire crust melted or broke apart, flooded with lava, and re-solidified. No one knows exactly why. Maybe it was a slow buildup of trapped heat, suffocating beneath an unmoving crust. Maybe it was a lack of tectonic escape routes, or maybe the planet simply crossed a threshold, a tipping point where geological pressure gave way to planetary fury. But whatever happened, Venus didn't come back from it. That's the most haunting part. Earth and Venus began the same, born from the same dust, warmed by the same sun, composed of the same basic materials. For billions of years, they may have walked the same path. But then slowly they diverged. Earth formed oceans, plate tectonics, a magnetic field. Life. Venus took another road, one defined by stagnation, suffocation, and collapse. Not in a moment, but over eons. And the scars of that transformation are still visible, frozen in Magellan's radar maps. But even in the aftermath, Venus isn't quiet. Near the end of its mission, Magellan performed gravity mapping, dipping lower into the atmosphere, risking the drag of the dense air to better sense the planet's interior. What it found defied expectations. Beneath the surface, the gravity field shifted, tugged and tilted by mass concentrations, suggesting a world still simmering with heat, still dynamic in its depths. Some volcanoes showed signs of being active not in the deep past, but possibly within the last few million years. And perhaps, just perhaps, some still are. Hints came from Earth-based observations too. Brief, flickering bright spots in the infrared, transient changes in sulfur dioxide in the upper atmosphere. These weren't conclusive, but they were enough to whisper possibility. Venus may not be dead. It may still be breathing, slowly, heavily, beneath its thick, toxic sky. And if it is, then it means our solar system still holds a planet-sized mystery, alive and evolving just next door. Magellan didn't find life. It didn't find cities, oceans, or forests. But what it gave us was something just as profound, a confrontation with extremity, a confrontation with what a planet like ours could become when its systems break. And it forced us to face the fragility of our own world in a way we hadn't before. Because Venus isn't some distant, irrelevant rock. It is Earth's twin. Not in appearance, but in origin. And its fate is a reminder. We are not immune. Our balance is delicate. Our climate, our geology, our atmosphere, they work in concert. And if they fall out of step, if the dance is disrupted, the transformation can be total. What Magellan gave us was more than maps. It gave us a warning etched in stone, written across a planet's surface in fire and ash. It said, "This is what happens when a world turns inward and cannot breathe." Magellan died as it lived, falling through the clouds consumed by the planet it revealed. In 1994, after completing over 15,000 orbits and mapping 98% of Venus, the spacecraft was deliberately plunged into the atmosphere. It had earned no less. This wasn't a crash. It was a burial, a final embrace between machine and mystery. As it descended, sensors briefly touched the upper haze before going silent. The surface was never reached intact. Temperatures of 900 degrees Fahrenheit, pressure 90 times Earth's, and winds that howled at hurricane speeds tore the probe apart before it could make a final report. But by then, the story had already been told. What Magellan revealed shifted our understanding of planetary evolution and our understanding of ourselves. Venus had once been a world with all the potential of Earth. It may even have had water. Some scientists believe shallow oceans could have existed billions of years ago, a place where life might have taken root. But something changed. The sun grew brighter. The atmosphere thickened. Carbon dioxide accumulated. The water evaporated. And with it, any chance for life. It didn't happen overnight. It was a slow burn. A runaway greenhouse effect that spiraled beyond recovery. And now Venus is the end result. A planet where lead melts on the surface, where acid rains down from the sky, where lightning crackles above volcanoes that may still rumble with unseen fire. We like to imagine apocalypse as something loud, something instant. But Venus teaches us otherwise. It teaches us that a planet can die slowly, imperceptibly, while still appearing whole from a distance. It can smother itself with its own breath. It can lose its oceans, not in a cataclysm, but to the quiet march of solar heat, molecule by molecule, until all that remains is desert and silence. And that's why Venus haunts us. Not because it's strange, but because it's familiar. Because in its hellscape, we see not only what it became, but what we could become. The runaway greenhouse effect that likely cooked Venus is not just theoretical here on Earth. It's a possibility, a distant edge we move closer to with every ton of carbon released. We have tectonics, yes, oceans, a magnetic field, but those things are not permanent. They're gifts. They require balance, and that balance is not guaranteed. Magellan didn't just map a planet, it held up a mirror. A distorted mirror, yes, warped by heat and pressure, but one that shows us the stakes of our choices. It showed us what happens when a planet's systems fail to regulate themselves, when feedback loops run unchecked, when cooling stops and heat builds and a world loses its rhythm. But there's something else too. Venus may be extreme, but it is not alien. In its volcanoes, we see echoes of our own. In its crust, the signs of strain and movement. In its potential for recent eruptions, the possibility that change still stirs within. And maybe, just maybe, that's where hope lies. Not for Venus, but for us. Because by understanding Venus, we learn how delicate planetary systems are. And with that understanding comes power. The power to avoid the same path. The power to protect what we have. Future missions are already on the horizon. NASA's Veritas and Da Vinci, Europe's Envision, new orbiters, new landers, maybe even drones. They will descend into those thick clouds, plunge into that infernal pressure, and try to learn what Magellan could not. They'll analyze the atmosphere, the rocks, the chemistry of the surface. They'll ask, did Venus ever have water? When did it lose it? Was it ever habitable? And could it be, just possibly, active today? These questions are not just about Venus. They are about the boundaries of life, about the rules of planetary survival, about how many Earths the universe might allow, and how many Venuses. Because out there around other stars, astronomers are finding more and more rocky planets. Many of them are Earth-size. Some are warm, some have clouds. Some even sit in that precious Goldilocks zone where liquid water could exist. But now we know better. Now we know that just being Earth-size isn't enough. A planet's history matters. Its geology matters. Its atmosphere. Its dance with its star. And Venus stands as a warning beacon. Not all Earths become havens. Some burn. So when we search for life beyond our world, we search with a new caution, with Venus in mind. We no longer look just for size and orbit. We look for signs of stability, of breath, of balance. Because one planet over, we have seen the alternative. Venus is not just a planet. It is a possibility, a path, a memory, a mirror. And thanks to Magellan, that mirror is no longer clouded. We looked beneath the veil, and what we saw wasn't just a world lost. It was a future we must fight to avoid. And in that way, Magellan's journey never truly ended. It lives on, in data, in warning, in the stories we tell ourselves about who we are and who we might yet become.